When finding the angles between two planes, you want to remember that cosine theta equals the dot product of both vectors over the product of their magnitudes. So you want to turn two of these equations into vector form. So the first one, let's name it A, and the second one, let's name it B. Vector A and vector B. So for vector A, to turn it into vector form, it would then be 1i plus 1j plus 0k. And to turn vector B into vector form, it would be 2i plus 1j minus 2k. And I get these coefficients from the coefficients right here. And these numbers after the equal sign, they don't matter because you don't need it to make an equation for a vector form. Once you get two of these vectors, you want to find their dot product. So dot product of vector A and B would be 2 times 1 plus 1 times 1 plus 0 times negative 2. And 0 times anything is 0. So then the dot product would be equal to 2 plus 1, which is 3. Now that you find the dot product, you want to find the magnitude of both A and B. And to find the magnitude of A, you just find the root of 1 squared plus 1 squared, which is 2. And for B, you find root of 2 squared plus 1 squared plus negative 2 squared, which is 2 squared is 4. 4 plus 4 is 8 plus 1 squared, which is 1. So 8 plus 1 would be 9. So it will be square root of 9. So cosine theta would equals to 3 over square root of 2 times square root of 9. Which, if you plug this into the calculator, 3 over square root of 2 times square root of 9 is square root of 2 over 2. And to find the angle, you would be finding theta. So theta would be inverse cosine square root of 2 over 2. So if you use this calculator, you would do shift mode setup. And actually you don't even have to do the mode. You could just do cosine, inverse cosine, and then plug in numbers square root of 2 over 2, which will then get pi over 4. So theta will equals to pi over 4, which is the angle between these two planes.